Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about algebra. Now the question that I've chosen to go through here is 2017 paper 1 question 1. And in this question we're given the function f of x equals 2x squared minus 7x minus 10. And we're asked to rewrite this function in the form a times x plus h to be squared plus k. So you should recognize that if I've been given a quadratic equation, okay, and I've been asked to rewrite this function in the form of x plus h to be squared. You should recognize that the x plus h to be squared, that's my quadratic equation in vertex form. Or another way of looking at it is sometimes people refer to it as completing the square. So I have the quadratic 2x squared minus 7x minus 10. And I need to rewrite this in the form a times x plus h to be squared plus k. So in order to get this in vertex form, you need to realize that my first problem is my coefficient of x squared. I can only get a quadratic in vertex form if the coefficient of x squared is 1, which means I need to try and get rid of this too. So because this is just an expression, really the only thing I can do here is factorize out 2. So I'm just going to factorize out 2. If I take 2 out of the first term, I'm left with x squared. 2 into the second term is minus 7 over 2x, and 2 into the last term is minus 5. So now I've rewritten my quadratic in the form x squared minus 7 over 2x minus 5. And when it's like this, I'll now be able to get that in the form of x plus h to be squared. So what we're concerned with on the next line is just the first two terms in my bracket. So just the x squared minus 7 over 2x. And for the moment we're going to ignore the minus 5. Now I need to figure out what number do I need to add to these two numbers in order to form a perfect square. And there's kind of a formula to work this out, or there's a way of doing it. So I need to look at the coefficient of x. The coefficient of x is minus 7 over 2. So I take my coefficient of x, which is minus 7 over 2, and I'm going to divide it by 2. Minus 7 over 2 divided by 2 is minus 7 over 4. Okay, we then take that number and we square it. So I'm now going to take minus 7 over 4 and I'm going to square it. Minus 7 over 4 to be squared, well 7 by 7 is 49, 4 by 4 is 16, and obviously a minus by minus is a plus. So that means, so what I do is I take the coefficient of x, I get half of it, and then I square that value. So now that means that if I add 49 over 16 to these two terms, then I'll be able to form a perfect square. Okay, but now I have another problem. Can't just randomly add 49 over 16 to an expression. So if I add 49 over 16, then I also need to take away 49 over 16. So I'm now also going to subtract 49 over 16. Because obviously in theory these would cancel each other out, and I'm not actually changing the value of the expression. So I add 49 over 16 and then I subtract 49 over 16, and then at the very end I obviously still have a minus 5. So actually I've just rewritten this, I've just added in these two terms. And the reason that we did that is because now these three terms will form a perfect square. I can rewrite x squared minus 7 over 2x plus 49 over 16 in the form of x plus h to be squared. So I still have a 2 outside, I don't need to do anything with that for the moment. And now I know that these can be written in the form of x plus something or minus something to be squared. So now I just need to figure out what value goes in here. And again, to do this, we look at the previous line and we look at the coefficient of x. The coefficient of x on the previous line was minus 7 over 2. So if I get half of that value, then I put it in here. Half of minus 7 over 2 is minus 7 over 4. So I can rewrite this as minus 7 over 4. So what I've done there is I know that x squared minus 7 over 2x plus 49 over 16 can actually be rewritten as x minus 7 over 4 to be squared. If I multiply this bracket by itself, I would end up with these three terms. So that's my x plus h to be squared. I'm happy enough with that for the moment. And then I also have a minus 49 minus 5. Minus 49 over 16 minus 5 is minus 129 over 16. But now this is the line that in 2017 a lot of students got caught out on. Because I want you to notice on this line it's 2 multiplied by the whole lot. So which means on this line it has to be 2 multiplied by the whole lot. So I still actually need another set of brackets. It's still 2 by all of this. And that poses a problem because now I don't actually have it in the form of a times x plus h to be squared plus k. The moment I have it in the form as if there was another set of brackets around it. Another set of brackets that I don't want. So I need to leave this in the form of a times x plus h to be squared plus k, where the k is on its own. So in order to get to the right form, I actually now need to go one line further. I'm not going to bother multiplying out my brackets, so I'm going to leave it as 2 times x minus 7 over 4 to be squared, and then 2 by minus 129 over 16 is minus 129 over 8. So now I've got it in the form of a times x plus h to be squared plus k. So this is my final answer. Now, just to double check, it asked me that it told me that a, h, and k should be elements of Q. Q means the rational numbers. A rational number is any number that can be written as a fraction in its simplest form, where the top of the fraction and the bottom of the fraction are whole numbers. So clearly this is 2 over 1, this is a rational number, 7 over 4 is rational, 129 over 8 is rational. I'm focusing on this and I'm highlighting this because when we get to the end of this video, we have to refer back to this, and it's very important that you know what a rational number is. So my final answer for the first part of this question is this. In the second part of this question, it says hence write the minimum point of f. Now the wording here is very important. Hence means use your answer to part A in order to answer part B. And the fact that the question says write as opposed to find, if it just says write down or just write the answer, that means that there's no work required. You should be able to just look at your previous answer and write down the answer without doing any work. So I want you to just think about what your original function was. I was given a quadratic function with a plus in front of the x squared, which means that I know it's a U shape. If there's a plus in front of the x squared, that's the shape that it will form. I know that this quadratic expression can be rewritten as 2 times x minus 7 over 4 to be squared minus 129 over 8. I know that this is another way of writing this quadratic. So the shape of this is a U. Now you can look straight at this and say what the minimum point is. So what they're referring to is clearly the point down here. Basically they're referring to the turning point. And if I have a quadratic in vertex form or as a perfect square, then I can just read off the minimum point. The minimum point, well, whatever the value at the end is, that's the y value of my coordinate. And whatever's in the brackets, I have to change the sign, and that's my x value. So instead of minus 7 over 4, it's plus 7 over 4. So a quadratic equation in vertex form, I can just read the minimum point. The minimum point of this quadratic is 7 over 4 minus 129 over 8. Often people get confused as to what the relevance of the 2 is here. If there's a coefficient in front of the bracket, it makes no difference to the minimum point. So supposing there was no 2 there, if this was my quadratic, this would still be the minimum point. If there was a 10 in front of my bracket, the minimum point doesn't change. So the fact that there's a number in front of my bracket doesn't actually affect the question. So my final answer there is just 7 over 4 minus 129 over 8. In C part 1 of this question, we're asked to explain why f must have 2 real roots. So of course what they're referring to when they say f is they're referring to my quadratic. F of x equals 2x squared minus 7x minus 10. Now you should know straight away that in order to prove that a quadratic has 2 real roots, that means that b squared minus 4ac is greater than or equal to 0. This is often referred to as the discriminant, and basically it's just a section from your minus b formula. So remember your minus b formula, this is just the bit that's in your square root. It's often called the discriminant. If the discriminant is greater than or equal to 0, then the quadratic has 2 real roots. So from my quadratic, I know that a is the number in front of x squared, which is 2, b is the number in front of x, which is minus 7, c is the number on its own, which is minus 10. So I just sub into b squared minus 4ac, and when I do that, I end up with 49 plus 80, so I end up with plus 129 is greater than or equal to 0. Clearly at this point, I can tick that and I can say that it's true. So once I've proven that b squared minus 4ac is greater than or equal to 0, I can conclude that therefore f has 2 real roots. For the final part of this question, now I've almost finished it, but just not quite. In C part 2, I've been asked to find the roots of the function in the form of p plus or minus the square root of q, where p and q are elements of q. Remember I said in the first part of this video that if it's an element of q, that means it's a rational number. Rational numbers are any numbers that can be written as fractions, where the top of the fraction and the bottom of the fraction are whole numbers. So to find the roots of a quadratic equation, clearly in this case we're going to have to use our minus b formula. If they tell me the roots are going to be in this form, then you should recognize that you're going to be using your minus b formula. So again, my a is 2, my b is minus 7, and my c is minus 10. And if you just sub it in, it works itself out handy enough. And I've gotten to the point where I have x is equal to 7 over 4 plus or minus the square root of 129 over 4. Now at this point we have to be very careful. I was asked to leave it in the form of p plus or minus the square root of q. P plus or minus the square root of q, where p and q are rational numbers. Well, 7 over 4 is rational. I'm happy enough with that. The top of the fraction and the bottom of the fraction are whole numbers, so there's no problem. But what about this term? I have the square root of 129 over 4. That's not a rational number. That's a fraction, and the top of the fraction is not a whole number. The square root of 129 is not a whole number. And also, the whole lot of this fraction is supposed to be in a square root. So the whole thing is supposed to be in a square root. So that's actually not my final answer. So the final answer in this case, you have to simplify down this second term. So my first one is just 7 over 4 plus or minus, and now the whole thing has to be in a square root. The whole thing is going to be in a square root, and I want it to be a fraction. The top of the fraction is going to be 129, and rather than having a 4 at the bottom, I have a square root of 16 at the bottom. So now I have it in the right form. This is the square root of a rational number, the square root of q. So this was the form you had to leave it in. I want you to just recognize that obviously 4, the square root of 16 and 4 are the same thing. So I've just manipulated my answer so it's in the form they asked me for. I think that was very tricky, because the rest of that C part 2 was relatively straightforward. It would have been very easy to just stop there. So I want you to get into the habit of always highlighting something like this. In June, when you're doing your Leaving Cert, in every question where it mentions Q or Z or N or any of those elements, then just make sure you highlight it. And when you get to your answer, you just go back and you double check it. Okay, so I hope this video made sense. If there's anything you're unsure of, then again, just let me know in class or send me an email and I'll try and clarify it for you.